Welcome to the DIY Honda Garage channel. The U1260 Diagnostic Trouble Code, DTC, specifically indicates a lost communication with auxiliary transmission fluid pump in a 2017 to 2022 Honda CRV. This code is primarily linked to communication issues between the vehicle's transmission control module, TCM, and the auxiliary transmission fluid pump. The auxiliary transmission fluid pump plays a critical role in the CVT, continuously variable transmission system, enabling proper fluid circulation and pressure, essential for optimal transmission performance. When this issue arises, it signifies an electrical fault rather than a mechanical transmission problem. Before proceeding with troubleshooting, it's crucial to ensure that the vehicle is turned on and prepare the Honda Diagnostic System, HDS, to check for any pending or confirmed DTCs as per diagnostic procedures. This presentation will guide you through a comprehensive, step-by-step troubleshooting process to isolate and resolve the U1260 code. DTC U1260 indicates a lost communication error with the auxiliary transmission fluid pump, a critical component of the Honda CR-V's continuously variable transmission system. This pump is responsible for circulating transmission fluid and maintaining adequate pressure within the system, ensuring smooth operation of the vehicle. The pump operates under the guidance of the Transmission Control Module, TCM, which communicates through electrical signals. The TCM itself resides within the vehicle's engine compartment, often near the battery, while the auxiliary transmission fluid pump is typically located on the transmission housing. This error may arise from issues in the electronic circuitry that connects these components. Thus, mechanical failure within the transmission is ruled out. Instead, the focus shifts to investigating potential electrical faults. Multiple potential causes are associated with DTC U1260, primarily focusing on electrical circuit integrity. One of the most common culprits is an electrical circuit problem, which impacts the communication signals sent between the auxiliary transmission fluid pump and the TCM. Additionally, poor connections or loose terminals in the wiring harness connecting these components can disrupt this critical communication. Furthermore, either the TCM or the auxiliary transmission fluid pump may be malfunctioning. Since this DTC specifically indicates a communication issue without mechanical fault, it becomes imperative to investigate these electrical connections thoroughly to determine the root cause of this failure, thus ensuring accurate diagnosis. When DTC U1260 is triggered, several symptoms may manifest, impacting the driver's experience. One of the most noticeable symptoms is poor transmission performance. The vehicle may experience erratic shifting, delayed engagement, or even potential stalling. Additionally, warning lights may illuminate on the dashboard, alerting the driver to transmission-related concerns. These visual cues indicate that a deeper investigation into the vehicle's systems is necessary. Errors in fluid pressure can also occur, further complicating the vehicle's operation, leading to additional strain on the transmission. Being aware of these symptoms ensures that drivers are more vigilant and can seek timely professional help to avoid further complications. The initial troubleshooting step for DTC U1260 involves powering the vehicle to the on mode, which allows the Honda Diagnostic System, HDS, to access and display relevant data from the Powertrain Control Module, PCM. Once the vehicle is in this mode, it is essential to check for any pending or confirmed DTCs within the PGM-FI Powertrain Control Module fuel injection system using the HDS tool. This initial scan will help determine if there are additional codes that may provide further context regarding the problem at hand. Identifying any other potential DTCs can guide the technician in narrowing down the faulty components or communication pathways. Thus, this first step is pivotal to ascertain a comprehensive view of the vehicle's diagnostic state. In the second step of troubleshooting DTC U1260, the technician will utilize the HDS to select the electrical oil pump activation function from the menu. This function allows the operator to command the auxiliary transmission fluid pump to operate for a specific duration of time, at least 5 seconds in this case. By performing this action, the system's response can be evaluated, and it is crucial to observe if any pending or confirmed DTCs arise following this activation test. If the DTC U1260 reappears, it indicates that the failure has indeed been duplicated under controlled conditions. This duplication is vital for confirming the validity of the original fault, providing a strong basis for further troubleshooting steps. Step 3 revolves around determining the potential failure area by first clearing the DTC U1260 using the HDS. After this code is cleared, turn the vehicle to the off mode and disconnect the auxiliary transmission fluid pump's 4P connector. This disconnection is crucial for isolating the circuits affecting the auxiliary transmission fluid pump. Next, the technician will turn the vehicle back to the on mode while ensuring that the connector remains disconnected. The voltage should then be measured between specified test points at the pump connector to establish whether battery voltage is present. This step is critical as it helps identify whether power is reaching the auxiliary fluid pump, which is essential for its function. In step 4, the technician will again measure the voltage between 2 specific test points. The conditions dictate that the vehicle must be in on mode, with the auxiliary transmission fluid pump 4P connector still disconnected. This measurement helps determine whether the power circuit is functioning correctly. Test point 1 refers to a female terminal on the auxiliary transmission fluid pump connector, while test point 2 is linked to body ground. Confirming battery voltage at this juncture signifies that power is reaching the pump connector, allowing further steps to check for communication issues. If there is no voltage, it suggests a fault in the power circuit that needs further investigation. Step 5 emphasizes the importance of checking for an open wire in the EOP-SIG, electronic oil pump signal, line. The technician must first turn the vehicle to the off mode and jump the SCS, service check button, line with the HDS. This will help safeguard the TCM from potential damage during tests. Post-jumping the line, the auxiliary transmission fluid pump 4P and TCM connectors should be disconnected. Resistance should then be measured between specified test points in the auxiliary pump connector and the TCM connector. Establishing a reading of 1.0 ohm or less confirms that the EOP-SIG wire is intact. If not, an open circuit needs to be repaired to ensure proper communication. In this 6th step, the technician continues to assess the integrity of the EOP-SIG line by measuring resistance between additional test points. As before, the vehicle must be in off mode, and both the auxiliary transmission fluid pump and TCM connectors must be disconnected. Resistance is evaluated between the auxiliary pump connector test point and body ground. A reading of 1 megaohm or more indicates that the wire is not shorted to ground. Conversely, if the resistance is below this threshold, it confirms a short to ground within the EOP-SIG wire, necessitating repairs. This assessment is crucial in ensuring all wiring connections are functioning properly before proceeding to testing other components. Step 7 requires the technician to reconnect all previously disconnected connectors for proper functionality assessment. The culmination of the troubleshooting process is testing the auxiliary transmission fluid pump to determine its operational status. If the pump is operational, It indicates that the earlier issues likely reside within the TCM itself or elsewhere in the system, necessitating further checks against authorized service information. Conversely, if the pump fails to operate correctly during this step, it confirms that the pump is faulty. Consequently, the pump would require replacement to restore normal function and resolve the diagnostic issue indicated by DTC U1260. In Step 8, the focus shifts to checking the EOPSTS, electronic oil pump status line, where a potential shorted wire may be present. Following the protocol, the technician starts by turning the vehicle to the off mode, jumping the SCS line with the HDS, and then disconnecting the TCM 50P connector. Resistance is measured between two specified test points, while ensuring that the vehicle remains in the off mode. A resistance reading confirming 1 megaohm or more indicates that the EOPSTS wire is intact, while a lower value suggests a short to ground scenario. If a short exists, it requires immediate rectification to safeguard against further complications within the system. In the 9th troubleshooting step, the technician must conduct an open wire check on the EOPSTS line. This also requires that the vehicle is in the off mode and EOPSTS test points remain disconnected from the TCM 50P connector. The resistance is measured between the specific test points within the EOPSTS line, and an acceptable reading of 1.0 ohm or less confirms the wire as functional. If the reading indicates an open circuit, it signifies a fault that requires repair along the line connecting the auxiliary transmission fluid pump to the TCM. Completing this step is vital to ensuring the integrity of the EOPSTS communication and operational signals. Step 10 focuses on assessing the EOPGND, electronic oil pump ground line, for any openings. The technician must verify that the vehicle remains in the off mode and measure the resistance using the specified test points. If the reading shows 1.0 ohm or less, it indicates that the EOPGND wire is functioning correctly. However, if it reads higher, an open wire exists between the auxiliary pump connector and body ground, necessitating repairs. Addressing this issue is essential, as a proper ground connection is critical for the auxiliary transmission fluid pump's functionality, ensuring reliable communication between systems throughout the vehicle. This 11th step involves checking fuse number F3, which is pertinent to the auxiliary transmission fluid pump's operation. The technician will assess whether the fuse is intact. If the fuse is operational, it confirms that the circuit is not the source of the communication failure. If it's blown, the fuse should be replaced, and further checking is necessary to prevent recurrent issues. Should the replacement fuse blow again, it signals an underlying short in the circuit linked to this fuse, which requires an in-depth inspection and repair. Ensuring that all fuses are in excellent condition is essential for the vehicle's electrical systems to maintain optimal performance across all components. In the 12th step, verifying the integrity of the auxiliary transmission fluid pump relay becomes essential. The first action entails removing this relay to conduct a standalone test for functionality. If the relay is found to be operational, it indicates that it does not contribute to the malfunction indicated by DTC U1260. On the contrary, if the relay is defective, it should be replaced. The relay plays a crucial role in controlling the power to the auxiliary pump. Thus, its reliability directly affects the system's performance. Properly functioning relays are pivotal for smooth interactions between electrical components, so addressing this step is vital. Step 13 demands the technician to measure voltage at the auxiliary transmission fluid pump relay 4P socket while keeping it disconnected. The goal is to compare voltage levels at the designated test points concerning body ground. This assessment ensures that the +B EOP electronic oil pump wire is functioning correctly. If the technician detects battery voltage, it confirms that the wire is intact and capable of supplying power to the pump when required. Conversely, should no voltage be present, it points toward an open circuit that needs repair. This step serves as a pivotal moment in confirming the integrity of the power delivery to the auxiliary pump. The 14th step revolves around measuring the resistance of the EOPRLY, electronic oil pump relay line. This is crucial for determining whether there is an open circuit between the auxiliary pump relay and the TCM. Following the prescribed process, the technician must ensure that the vehicle is in the off mode and the relevant connectors are disconnected. A reading of 1.0 ohm or less confirms that the EOPRLY is intact. If the measurement indicates a higher resistance value, it denotes an open wire that could impede communication or operation between the TCM and the auxiliary transmission fluid pump. Identifying and repairing this is essential for restoring normal operation. In the final troubleshooting step, the focus shifts to assessing the EOPVB, electronic oil pump voltage B line, by measuring the resistance between designated test points. If the resistance reading shows 1.0 ohm or less, it indicates the EOPVB wire is functional. However, a higher reading would confirm an open circuit that must be repaired, specifically focusing on the connections between the auxiliary pump relay and the fluid pump itself. If the EOPVB line is intact and all previous steps confirm component functionality, the technician should further consult any authorized service information pertinent to the issues at hand. In any case, resolving these issues is crucial for ensuring reliable communication and performance from the auxiliary transmission fluid pump. After completing all troubleshooting steps for DTC U1260, it is crucial to conduct final repair verifications. The technician should perform a series of tests to confirm that all components involved are functioning correctly. This includes rechecking the operation of the auxiliary transmission fluid pump, ensuring that the TCM communicates appropriately, and verifying that all relevant connections are secure and free from faults. Also, it's important to recheck for any DTCs using the HDS to confirm that no further erroneous codes are triggered. Only when all tests yield positive results should the vehicle be considered ready for normal operation. Preventive maintenance is essential for minimizing the risk of DTC U1260 and similar issues. Regular inspection of electrical connections between the auxiliary transmission fluid pump and the TCM is critical. Technicians should routinely check harnesses for wear, dirt, or corrosion that could disrupt communication and power delivery. Moreover, ensuring that fluid levels are maintained within specified ranges can help further reduce unnecessary strain on the auxiliary pump. By adopting these practices, vehicle owners can maintain the integrity of the transmission system, ultimately extending the life of critical components and minimizing future repair costs. In conclusion, addressing DTC U1260, which pertains to the loss of communication with the auxiliary transmission fluid pump, involves a systematic approach focused on electrical integrity. Emphasis on initial diagnostics, followed by targeted checks for connections, resistance measurements, and comprehensive component tests are pivotal in isolating the issue. Awareness of the various potential causes and symptoms informs proactive diagnostics. Furthermore, implementing preventive maintenance plays a crucial role in sustaining system reliability over time. By following these guidelines, technicians and vehicle owners alike can ensure optimal transmission function and avoid the inconveniences associated with periodic communication failures. Please like and subscribe to the channel. See you next time.